Hi, I am Atanu. In this tutorial video, you learn all geometric figures, their definition and properties. Geometric shapes are the figure that represent the object of surrounding us of our daily life. Based on the dimension, geometric figures are classified into the two types. One is 2D shapes and another is the 3D shapes. 2D shapes are those shapes that can be plotted on a plane on the two coordinates required, but for the 3D shape it's required the three coordinate because this is the 3D structure. Shapes also classified into two types. One is the regular geometric shape and another is the irregular geometric shape. Now look at this. If the figure is symmetric, for example, this is the figure of the triangle, this is the equilateral triangle because all sides are equal. This is the square, all sides are equal. This is symmetric figure. Okay, and this is also hexagon, all sides are equal. So these figure are the example of the regular geometric shapes. What are those irregular geometric shapes? Scalene triangle is the example of the irregular geometric shape. Look at this, all three sides are unequal. Irregular trapezium also example of the irregular geometric shape. Clear? You must remember these all geometric figures are the closed shape. Next we learn about point, lines, angles and plane. These are the fundamental concepts we should know before learn any figure in geometry. First we learn about the points. Point is a dot in a plane. Let's consider this is a plane 2D and we can represent this plane as XY plane. Okay, because this is X axis and this is Y axis. And if we consider any point, look at this, we get any point by the X and Y coordinate. Look at this, different point. So let's consider this point is 1 and 3. The coordinate is 1, 3. X coordinate is 1 and Y coordinate is 3. Another point is here 3.1. This is 2 minus 3. This is minus 3 minus 2. This is minus 3 1. This is 1 0, minus 4 0, 0 4. These are the coordinate of the point. So point is used to locate a position. Okay, why a point represent a position? Because let's consider point A. The location is 1, 3. What that mean? If you walk from this origin, that is 0 0, so scale is there 1:100. Clear? So A point represent a location of 1 3 means 100 meter east from the origin and 300 meter to the north. Clear? Now how we can locate a point in three-dimensional space? You have to suppose you take position here. Is 1 2 3. What that mean? You just consider this figure. Suppose all this division are the 1 centimeter along the x, y and z axis, and the coordinate of the A given 1, 2, 3. What that mean? You have to first move from the origin along the x axis 1 centimeter. Okay, then you have to then you have to move along the y-axis 2 centimeter. 1 2 means here. Then you have to move along the z-axis 3 centimeter. Now we learn the type of points. So first we learn the collinear and non-collinear points. When more than 2 points lie on a same line, then we can say the points are collinear. Look at this. Here A, B, C, D, 4 points are there. If I draw a line through this ABC, the 3 points lie on this line, but D is not lie on this line. So we can say that in this figure ABC points are collinear, whereas ABD or ABCD or BCD, this pair are non-collinear. Clear? So for the collinear point of view, you have to consider 3 or more than 3 points. Clear? Next we learn another type of the points, coplanar, non-coplanar. So what is coplanar and non-coplanar points? If 4 or more than 4 points lie on the same plane, then we can say they are the coplanar points. Look at this diagram. Here A, B, C, D, E. Out of this 5 points, A, B, C and E, A, B, C and E, these 4 points lie on this plane XY, but D is not lie on this XY plane. Clear? Look at this. So this is the A, B, C and E. These 4 points lie on the same plane, but D is outside this XY plane. So we can say that A, B, C, E are the coplanar points. But when we include this with D, any of the 4 or more than 4 group, for example A, D, B, C are not the coplanar points. Next we learn lines. So let's consider point A and B. Now draw this here. So this is a example of line, and this line both side having no end. Okay, that is the reason we represent a line by the arrow the both side. Clear? So we can extend the both side infinitely. This line also we can represent by M. You can say that M is a line. Or we can say that AB is a line. Next we learn the line segment. Now look at this figure. Point A and point B, if we connect, we get a line segment. We can say that what are the properties of the line segment? It has defined or definite endpoints. We can say the two endpoints. It can represent as this. Clear? So having the fixed length. Okay. For example, we consider from here to here. So this length is 3 centimeter. Clear? You can say CD having the fixed length 3 centimeter. So each line segment having definite length. Next we learn about ray. It is a line having the one definite endpoint but other endpoint extended to infinite distance at one direction. Clear? Let's take one example. If we consider point here and extended to infinite direction, we have to put one arrow here, and from this point we draw another line to infinite direction with the arrow. This is the point A, okay, and here B and here C. So we can say that AB and represent with this one side arrow and AC are the ray. Clear? Let's discuss all types of the lines. So, this is a straight line. Okay. If we represent this with the arrow both side, then we can say that AB is a straight line. Clear? Why it is a straight line? Because it's connect the 2 points the shortest path without change the direction. Clear? That is the reason it is called the straight line. Or we can say, we have already discussed, it is a line. Okay. Next is curved line. What is curved line? It is smooth and bend line. Okay. So there are the different type of the curves are there. When the curve do not cross, then we can say it is the simple curve. And non-simple curve, when the curve cross, then it is called the non-simple curve. Clear? This is the example of a curve, and we can represent this with the algebraic equation, that is y square is equal to 2x. It is well known parabolic curve. Okay, next we learn the horizontal lines. Okay, this two line completed. What is horizontal line? It is parallel to the x-axis and from left to right direction. All straight line parallel to the x-axis from left to right is called the horizontal line. So what is the equation of this? We know that this is y is equal to 0 of this x-axis, and this is the origin, and these are the all horizontal line. Look at this. You follow this line, moving line. These all are the horizontal lines. Clear? So these are the horizontal line. Similarly, we can define the vertical line also. Okay, what is vertical line? This is the y-axis, and this is the origin, and the equation of the y-axis is x is equal to 0. If we draw vertical to the x-axis or parallel to the y-axis, then these lines are the vertical lines. Clear? Next we learn the parallel line. So this is the parallel line, and we can represent, let's consider AB and CD are parallel, so we can write as AB parallel to CD. So all horizontal line, we can say one example of the parallel line. Now look at this. This is y is equal to 8 and this line is y is equal to 2. These two lines are the horizontal line parallel to the x-axis, so they both are parallel to each other. Clear? Suppose we consider here A and B and also C and D, then we can write as AB parallel to CD. Similarly, all vertical line also parallel line, but it is not necessary it should be always horizontal line or the vertical line. It could be like this. This is also a example of the parallel line. Okay, this is the B. Now we learn the intersecting line. If AB and CD intersect at O, then we can say that AB and CD are intersecting line. This is y is equal to x plus 1 and this is y is equal to 2x plus 3. They intersect, for example, at P. Next we learn the perpendicular line. When the two lines intersect each other with 90 degree, this is 90 degree, okay, then we can say they are the perpendicular to each other. Let's take example AB and CD. So we can write as CD is perpendicular to AB. Clear? Next is transversal line. If two lines, they may be intersecting or parallel, and if the third line intersect these two lines, then we can say that this line, for example P, and this line is, for example, M and N. So P is transversal to line M and N. Clear? There should be an arrow. Or we can say, when a line, for example P, intersect two lines, that is M and N, at distinct point, these points are different, then we can say this P is transversal to M and P. And you must consider this, these three lines should be in one plane. Why? It is necessary to, for the transversal, three lines should be lie in the same plane. Let's take this example. From this top view, it is look like EF line transversal to AB and CD, but actually they are not. Why? Now look at this. They lie in the different plane. That is the reason actually they don't cross each other. Means this EF line not cross AB and CD. So we can say that EF cannot be the transversal of AB, and this is the end of this video. Thank you for watching.